So there is another way, that redox can be explained in various ways. In terms of oxygen, we have seen in terms of electron transfer, and we have seen in the terms of oxidation number changes. This is basically redox in terms of hydrogen. In terms of hydrogen, the definition says oxidation is loss of hydrogen by a compound, by a substance. Oxidized means loss of hydrogen. Reduction is gain of hydrogen by a compound. Reduction is gain of hydrogen by a compound. Reduced mean oxidizing agent. Oxidized mean reducing agent. In terms of hydrogen, if we look at these examples, they'll clear the concept. This is methane gas, CH4. When we mix it with chlorine, this is an organic reaction, and normally UV, the sunlight is provided, diffuse sunlight that catalyzes this reaction, that provide energy for this reaction, basically free radical substitution reaction. You need not to know this before organic, but somehow the condition is UV is provided. You can see this compound has lost hydrogen, loss of hydrogen, I said, CH4 to CH3 and Cl. Again, of electronegative element is, look at, it is oxidized by the definition. And chlorine has gained hydrogen to turn into what? HCl. I said gain of hydrogen. This compound has lost hydrogen, this has gain hydrogen. Redox, the coupled reaction. One substance is oxidized, other is reduced. It is reduced because of gaining hydrogen. Reduction is gain. Look at, reduction is gain. Oxidation is loss, just like electrons. So reduction has gained what? Gain of hydrogen. This compound has lost hydrogen, it has gained hydrogen. So chlorine has gain of hydrogen, makes it as reduction to occur, reduced, so it's an oxidizing agent. And simultaneously this compound has lost hydrogen, oxidized, it's a reducing agent. Same example here, H2S has lost hydrogen to turn into only S, and loss of hydrogen, oxidation is loss, oxidized, mean it's a reducing agent. And chlorine has gain hydrogen to turn into HCl, and gain of hydrogen is reduced, so it's an oxidizing agent. So redox in terms of hydrogen can be defined by the word oxidation is loss of hydrogen and reduction is gain of hydrogen. As in the electron transfer, we see in oxidation is loss of electron, reduction is gain of electron. Same here in terms of hydrogen. You need to be careful. It has lost hydrogen, so it is oxidation is loss of hydrogen here, oxidized. Gain hydrogen, reduced. And opposite it occurs in the terms of oxidizing agent and reducing agent. It is reduced, so it's oxidizing agent. It is oxidized, so it's reducing agent. Same here, okay? So these are two important examples to explain this idea, the redox in terms of hydrogen. When you ask in terms of hydrogen, you explain in terms of hydrogen. When you ask precisely in terms of oxygen, you explain in terms of oxygen. When you ask in terms of electron transfer, you explain in terms of electron transfer. And when he says in terms of oxidation number, you put oxidation number. But when sometime the examiner asks simply explain redox, it's easier for you to explain in terms of oxidation number. It's so easy. You can find out H2S, hydrogen is group 1, so plus 1 into 2 mean plus 2. Group 1 is given the oxidation number first. And sulfur group 6, so minus 2 to make it 0. Cl2, it is 0. Starting original genuine form, oxidation number 0. Hydrogen group 1 plus 1 is minus 1. Sulfur in genuine form, original form, uncombined form, unreacted form, yet to open its account, so it is what? 0. You can see yourself, hydrogen's oxidation number stays same on both sides, no change. But sulfur oxidation number has fallen from minus 2, increased from minus 2 to 0, okay, because 0 is bigger term, so it means it is oxidized. So even in terms of oxidation number, you can find out H2S is oxidized, and it is acting as what? Reducing agent. And chlorine 0 to minus 1, I mean 0 to -1. Loss in oxidation number, and loss in oxidation number is what? Reduced. And even in terms of hydrogen, you see it is reduced. So it's acting as what? Oxidizing agent. So you can explain this.